First of all, I welcome each and every one of you to this 5th annual iPoLS meeting. I know that many of you traveled from far to attend this gathering, like we did last year when we went to Munich. I think the level of enthusiasm and the growth of this network is a testimony to the importance of this iPoLS network, which is intended for young scientists to foster interactions between them, graduate students and postdocs, to discuss physics-based type approaches to solving major problems in biology. This creation of this network was initiated by and set up, but would not have been possible at all without the extraordinary vision and foresight of two key people who are in the audience, luckily for us, Dr. Preston Blagayo and Dr. Kamal Shukla. They had this creative idea in 2008, and a few of us met in a small room at NSF, and the idea to create this network was born. And in the intervening 6 or 7 years, the people who've been at the inception, like Kirby, Jose, and others, have seen this network grow. It has been fantastic to see the interaction between the students, postdocs, and the PIs. I hope that will continue here and moving forward. I believe that much of the fruits of this vision that these two individuals had will only become apparent in 10 to 15 years as the younger ones become their own PIs, and who knows how this network will grow. And therefore, we, as an international community, there are people from all over, I'm not going to remember all the countries, are really beneficiaries of the leadership of Preston and Kamal. So I would like to now acknowledge their human efforts in bringing this program to fruition and for their continued support for its growth. So let's give them a hand. I urge the young scientists to not only network with each other, which is one of the goals of the network, but also interact with the PIs and don't be shy in talking to them, even though we have a tendency to socialize with each other. And we can do this at any time, anywhere. So please butt in and have discussions with the PIs. The logistics of the program, which would have absolutely given me nightmares, was superbly handled by Sarah Bradley, and this is the first of many thanks I wish to extend to her publicly. Thank you, Sarah. It's now my privilege to introduce our provost, Dr. Mary Ann Rankin, who will give a few opening remarks to inaugurate the meeting.
Thank you, Dave. Well, it's a great pleasure to be here this morning to welcome you on behalf of the University of Maryland to the 5th conference of iPoLS. It's such an interesting endeavor here. I was just talking to Susan Singer here about it. I think this is so creative and wise of the founders and NSF and you all for participating in it, for founding it, for supporting it, and for participating. These kinds of initiatives that happen at the connections between disciplines are so difficult sometimes to navigate, and particularly trying to acquire the tools as students from both sides, from the biology and the physics side, can be very challenging. So I applaud you all for doing this. I'm so excited that Maryland is one of the founding universities in this network that has been established. I'm very proud of us for doing that. So, I'd like to know how many of you all consider yourselves biologists first? A few. Yes, good. Okay, I am a biologist. I grew up that way. How many of you consider yourselves physicists? So most of you are sort of going from the physics side to the biology side. That's very interesting. I was for a long time, seemed like most of my life, I was dean of the College of Science at the University of Texas at Austin, and I watched, as dean, physics was one of my departments, as was biology, of course, and I came up out of biology. But I watched the physics department change over those years from being entirely physics focused to sort of noticing biology and then realizing that this was an exciting possibility for exploring physics problems. So kind of being at the fringes of biology, but looking at membranes and things like that that were kind of relevant to nonlinear dynamics and these kinds of things, to actually then hiring people who maybe were, if not biologists first, at least deeply grounded in biology, but could still bring the physics tools, but who had to have a biology lab set up. That's what I watched as dean, molecular biology or whatever, but were embedded in among the physics colleagues. And I think the science grew stronger and stronger in both directions. And I think this is the kind of nexus where really new insights and innovations into all sorts of things, medicine, neuroscience, and probably physical phenomena are going to happen. So I really applaud you all for being brave enough to look at making an interdisciplinary choice like this and trying to acquire the tools from both quite challenging and different disciplines. It's really, really exciting. I think it's also probably going to continue for a while to be a challenge as you go forward to acquire and continue to acquire both sides, but also to make yourself understood in various ways to the two different disciplines when you have something really important to impart. So we'll hope that NSF continues to support these kinds of interdisciplinary initiatives so you can get grant funding and these kinds of things. Anyway, I've gone on long enough. I don't want to delay your meeting. I wish I could stay and see some of it. Unfortunately, I'm provost. That means I don't get to do many very fun things. I have to go back and have many, many meetings. But I hope that at some point I will have the fun of welcoming you to the University of Maryland in another way, say as faculty members or postdocs or something like that. You know, this is a great place to have a meeting, great venue and everything, but I'm kind of sorry that you're not having it in College Park on our campus so you could see us in person. But if you have a chance, I really wish that you would do that, come out and look at the campus, meet our physicists and some of our biologists firsthand and take a look at us. Anyway, once again, welcome from the University of Maryland. I hope you have a terrific meeting and go on to do truly wonderful things together. Thanks.
And I'm Chris, I'm going to introduce our next speaker.
So as Dave Kamal said, I'm Kastam Vladar, and I'm responsible at NSF for the program called Physics and Living Systems. I also want to thank all the PIs, because without them, this effort, the network would not have survived. The huge broad support at NSF from the Director's Office, from the National Office, the Education Office, and all the divisions that actually involved in co-funding this network. I want to thank everyone. And I just want to say one word. This network was created because we wanted to have people early on trained in biology and physics to work at this interface. My generation and the previous generation mostly consisted of people who had a very successful career in condensed matter physics or high energy physics, and then midlife they switched to biology. But if you are not trained early on in the field, you never become native. So we decided that this is actually extremely important to start early on. And I'm so happy that there are so many young people here that actually the next generation of physicists and biologists working at the interface of physics and biology. So thank you so much, and I want to introduce Susan Singer from the Education Director. She's the Division Director of Division of Undergraduate Education. And as we were talking earlier, in fact, that education has to start probably even in high school. So it has to be really integrated from high school to undergraduate to graduate and also and so forth. And this will be the future, I think. So thank you all and have a great evening.
Thanks so much for the opportunity to join all my colleagues in welcoming you and welcoming you on behalf of the NSF. I decided I'd offer a little visual relief with a few slides for you. I started out in life as an engineer, as an undergraduate, and went on to graduate school in biology, and that was about 3 decades ago, and there were work opportunities like you're having today, so it's incredibly exciting to see the really innovative Renaissance thinking that you're doing. But I wanted to start by saying that you're in really good company with Renaissance thinkers. I don't know if you're familiar with Carl Nicholas's book on plant physics, but I really appreciated the historical perspective he has in the beginning with Galileo, who actually figured out with construction materials where you have strengths on the outside. That all came from looking at plants, which you could probably now guess my predilection. I think they're pretty cool. And then Leonardo da Vinci, as you think about parachutes and falling from the sky from very high heights. Dandelions are pretty awesome, and also the seeds from maple trees. If you see them spinning in the spring, sometimes young children peel them back and make noses to put on their noses. But some really interesting things in terms of bio-inspired things that led to physics, to engineering. And there's a lot that's been bubbling up in terms of bio-inspiration. And so I tried to pick some examples that had resonated with me that were not the really, really amazing cutting-edge things that you're talking about today. I'm a big fan of Angie Belcher at MIT and all the interesting work she's doing with viruses and making batteries from there. Maybe Cole's work at Berkeley, everything from looking at what happens when kelp gets, sea algae gets whipped back and forth in the tidal zone, and what do we understand from physics, and how does the biology inform that? Or Adam Summers' work at Friday Harbor Lab, that clingfish is pretty awesome. The clingfish lower side is stronger than any kind of suction cup we know of, and they can lift huge things with it. What can we learn from that? So I was thinking about, from the outside in, and then the work you're doing, looking from the little very, very small scale molecular biophysics, from physics, and trying to work out. There's just such a huge, exciting space, and what a great day you have ahead. NSF has been interested in this territory for a very long time. They funded a study at the National Academies that produced this report in New Biology for the 21st century. And what I find very exciting about this kind of thinking is that we've got these huge problems to solve, right? Food, energy, feeding the world, the environment, health, and we can ask the questions at the biological level, but without really strong physics underpinnings and other things, we're not going to be able to solve these big problems. And there are a number of quotes in this report, but one that I think may resonate with your crowd at all, thinking about Mary Ann's question about who's a physicist, who's a biologist. By this definition, I think you all count as the new biologist. You have this deep knowledge in one discipline, and it may not be biology at all. It could be physics, it could be engineering, but this fluency, this ability to cross different conceptual fields and really engage each other. And we're now talking about this convergence, again, another National Academies report that's out, but thinking hard about how we actually merge these fields to solve important problems like cancer. Very exciting work, and I think you're truly the first generation of convergence scientists. And to be really good at that, we need some kind of convergence creel, right? We need to be able to talk with each other, not just, snag each other's tools for our own purposes, but to really think innovatively together. And so that up here I have a few different examples of things that may inspire you, be resources for you. I really appreciated the Scientific American article on the right here about how diversity makes us smarter. It's a synthesis of a lot of research on how groups solve complex problems. And the more diverse a group is in all sorts of ways, not just academic background, but prior experiences, parts of the world, cultures that you come from, which is why the Savvy program at NSF is so valuable. That's what was a piece of what started your work here, but your work actually informed the development of the Savvy program as well. So the idea we need to really work together, there is a whole science of team science. There's a recent, I've got another National Academies report out that the NSF funded, dissecting what we know from a research perspective about how to make teams like the teams you're building really effective. So a lot of it you're doing intuitively right now, and I hope we're all going to learn from what's making these partnerships from all of you very successful. And then to just come back to my colleague's point, we need to think about how we're going to get the next generation of you. What you're doing is so remarkable and so wonderful. We're going to need many, many more folks out there that are thinking and engaging in the way all of you are. So at the undergrad level, there's a huge push in the United States on creating an introductory physics course for life scientists. And it's fascinating to watch my physics and life science colleagues come together and figure out how to work together and what's really important for students to understand and to be able to do in these contexts. There's even now a Gordon Research Conference that's in place in this area. And if you go back even earlier, again in the US, in the K-12 curriculum, the National Academies have a framework for K-12 science education, and we have a set of that are not implemented by every state, but there's a next generation science standards that states have developed together. And one of the key things there is to develop cross-cutting concepts in all of the science courses from the time children are very young in the kindergarten. So they'll grow up with the kind of fluency that all of you are developing, and that folks that are my age that have always been a single discipline, will never have that native fluency yet. So you'll be part of that adventure too. So with that, I'd like to thank you I'm from the Midwest, for breaking down silos and engaging each other, and I wish you a really terrific day. Thanks.